Hi guys, welcome back to another video of Expert Guides Tutorial and Review Center. I am John Matthew Lim, your instructor for today, and today we will be going over some chemistry topics. So for today, we will be talking about the properties of matter. But before that, a little something about myself. My name is John Matthew Lim, and I graduated high school from Xavier School, San Juan. I then went on to University of Santo Tomas to get my bachelor's degree in pharmacy. And then currently I am a Doctor of Medicine student at St. Luke's Medical Center, College of Medicine. Okay, so now let's start. So before we do anything, let us first define what is matter. Okay, so matter is anything that has mass and takes up space. Okay, so basically it's anything that you can touch. And there are actually 5 states of matter. Alright, there are solids, liquids, gases, plasma, and Bose-Einstein condensate. Alright, the first 3, the solid, liquid, and gas, these are the most common forms of matter, states of matter. Plasma and Bose-Einstein condensate exist only in extreme temperatures. Plasma exists in very hot temperatures, while Bose-Einstein condensates exist in very, very cold temperatures. Alright, so let me ask you, how about light, or how about heat made from fires? Okay, so when you turn on the lights, do you feel the weight of light? Do you feel heavier when you turn on the light? How about heat? When you put your hands near a flame, right, for warmth, do you feel weight, something heavy? No, right? You can't also touch these things. You can't hold them. Therefore, these things are not matter. These are actually energies. Okay? Now, why do we need to study matter? So, we have to study matter to know its properties, so that we can know if a material is useful or not. Alright? And lastly, it's to know how to recycle and reduce our waste, because as humans, we don't want to create a lot of waste. Alright, so how can we describe matter? There are 2 ways. We can look at 2 things, physical properties and chemical properties. Alright, physical properties are things that you can see, hear, taste, and touch. So these are the 5 senses. While chemical properties, these are things that require a reaction from another material. Okay, so you need 2 materials to react with one another to create a chemical change, to know the chemical property. Alright, so let's start with physical properties. These are the characteristics readily observed without changing its composition or identity. Okay, so that's very important. It doesn't change its composition or identity. So it's identified by using the 5 senses, or you can also use measuring tools like a ruler, like a measuring tape. So these are examples, are size, shape, color, etc. Alright, so below are examples and pictures of materials that you can describe the physical properties of. We will go to them later. Alright, so let's start with hardness. What is hardness? Hardness is the ability of a material to be rigid and resist pressure. Examples of these are metals, wood, and diamonds. Diamonds are actually the hardest material on Earth. So when you put pressure on these things, when you push them, alright, if you punch them, you push them, you try to break them, it's very hard for them to break because they resist the pressure. Alright, so that's hardness. Next is brittleness. So brittleness is defined as the materials that can break and crumble under pressure. That means if you put pressure on them, you try to hit them, you punch them, you put your weight on them, they can break and crumble. Examples of this are glass and porcelain. So if you put your weight on these, if you smash them on the floor, they will break and they will crumble. Alright, so hardness and brittleness are actually opposites. Next, flexibility. Flexibility is the ability of a material to bend without breaking. Okay, so we have here plastic straws and bamboo. So you can bend plastic straws and they will not break. Bamboo, on the other hand, this is a plant that is very flexible because it can bend a lot. You can bend it to almost fold, but it will not break. Alright? Bamboo is very flexible. Next is elasticity. So this is the ability of a material to stretch and then return to its original shape. So the classic example is the rubber band. You try to stretch the rubber band, and then after a while, when you let go, it will snap back into its original shape, right? So we say rubber bands are elastic. Next is ductility. Ductility is the ability of a material to stretch and remain stretched so that you can create wires, okay? So this is very common with metals. There are metals, you can actually stretch them, and then they will be formed into wires, and they will stay as wires. They will remain stretched. Next one is conductivity. This is the ability of a material to let heat or electricity pass through them. Alright? So, most common conductive materials are copper wires and also other metals that you turn into wires. So, copper wires are used for electrical wiring so that electricity passes through. So, yung mga charger, yung mga plugs, these are electrically conductive. While metals, on the other hand, they're also electrically conductive and they're also very heat conductive. That's why pots and pans used for cooking are very good because they conduct heat well so that you can cook your food. Okay? Next is malleability. This is the ability of a material to be hammered into flat sheets. So most of these are metals also, like silver, iron, and aluminum. Alright, so we have metals here. You can make them into flat sheets, also known as yung hierro. Okay? So let's go to chemical properties. So these are characteristics not readily observed. You need some special tools to measure them. Alright? It's hard to describe them by themselves because these properties usually come out or can only be observed when the material reacts with another material chemically. This will lead into a change in composition or identity. Right? Remember, physical properties, there's no change in identity. While in chemical properties, there is a change in identity. So, examples here are combustibility, flammability, and biodegradability. So, we have here examples. A metal chain has rust formation, while this piece of wood will burn. Alright? Burning is actually a chemical process. Alright, so what are these chemical properties? We have combustibility, which is defined as the ability of a material to burn. Okay, so examples here are dried leaves, a piece of wood, you have paper, gasoline, and alcohol. These things can burn, right? You can light them on fire. So to know if something is combustible, you can ask yourself, can it burn? Okay, can it burn? So if the answer is yes, then it's combustible. Now, how about flammability? What's the difference between those two, combustibility and flammability? Flammability, it measures how easy it is for a material to catch fire or to ignite. Alright, examples here are alcohol and gasoline. So these two, they catch fire very, very easily. So since they catch fire easily, they are flammable. You can ask yourself, does it burn easily? If the answer is yes, then that material is flammable. How about a piece of wood? Is that flammable? Can you ask yourself, does it burn easily? Actually, wood takes a longer time to burn than alcohol or gasoline. So it is not flammable. However, it is combustible. Because if you ask yourself, can wood burn? Yes, it can burn. So it's combustible, but not flammable. While gasoline, can it burn? Yes, it's combustible. Does it burn easily? Yes, then it's also flammable. Okay? Now, next one is biodegradable. This is the ability of a material to easily decompose. Okay? It usually takes weeks to months. And you can turn them into compost. So examples here are food scraps, such as like a banana peel. If you leave it out for a few weeks, it will turn into compost. Compost is actually decomposed material that is very nutritious for the soil. So it's very good for agriculture and farming. Alright, so next is non-biodegradable. These are materials that take a longer time to decompose. It takes hundreds of years. So and you cannot make them into compost. Examples of these are plastics. Okay, plastic containers, plastic utensils, these take a very long time to decompose. Now, let's talk about the changes in matter. So, first is a physical change. So, this is a change in form and appearance without change in the composition or identity. What does that mean? Let's say I have a rock and I break the rock into smaller pieces. Is there a change in identity? No, because it's still a rock. But now it's smaller rocks, it's just pieces of rocks. So, we can classify breaking a rock as physical change. How about tearing paper? So I take a piece of paper, I know it's paper, I tear it apart. Now it's smaller pieces of paper, but it's still paper. So the composition or the identity is still the same. Therefore, tearing a piece of paper is a physical change. How about this? Melting ice or boiling water to create vapor or gas. So is this a physical change? Let's see. Let's see if the identity changed. So ice is actually very cold water. So it's water. Water is, well, it's water, normal water. And then if you boil water, it turns into gas, but it's still water. So in all of these examples, it's the identity of the water is still water, even if there is a phase change. Okay, so phase change is actually a change in the state of matter from solid to liquid to gas. Okay, so changing from solid liquid to gas is a physical change. Alright, now let's talk about chemical change. So these are changes in an object with a change in its composition. Or it can also be the formation of a new product with a new identity. So, for example, burning a piece of wood. When you burn it, it turns into ashes. Okay, so from wood, it turned into ashes. So the composition actually changed. Therefore, it's a chemical change. In order for combustion to occur, or burning, it needs three things: heat, fuel, and oxygen. Okay, so remember that. And another one is formation of rust or kalawang. So you have a metal chain, you leave it in the rain, and oxygen, exposed to oxygen. What will happen is the formation of rust, which is a new product, or yeah, it's a new product. Okay, so from metal it turns into rust. So that's a chemical change. Now, what are the evidences of chemical change? Number one, you have the formation of a new product. So an example here is a metal nail. You expose it to oxygen and the water, it will form rust. This actually shows oxidation. Okay, so from metal it formed something new, which is rust. Formation of new product. Number two, formation of a gas. So usually this is similar to formation of a new product. An example here is baking soda mixed with vinegar. When you mix these two, bubbles will form, and then baking soda starts to curdle or form lumps. Alright, so a picture of that is this. So you have a liquid and then you have a solid. When you mix them together, look what happened. Bubbles started to form. Okay, the bubbles are indication that gas has been formed. Alright, which is a chemical change. Next we have is release or absorption of heat. So when the metal is soaked in an acid, heat is released as the metal starts to corrode. Okay, because the acid will melt the metal. Alright, so a picture of that is this. Notice here, in the before picture, you have a metal in an acid. Alright, and the after picture, the metal starts to melt away. It starts to corrode, and then the water turns red to show that heat is being released. Okay, so when heat is released, it's an evidence of chemical change. And lastly, there is the formation of a precipitate. Okay, so when milk spoils, alright, there becomes a foul odor, and then there will be precipitation. Okay, so precipitate is a word for solid particles that begin to form in a solution that does not have solid particles before. What does that mean? So let's look at this picture. So the two test tubes on the left, you can see they are clear. right? Test tube 1, test tube 2, they are clear. But when you mix them together, look what happened. White particles start to form, all right? Those white particles are solids that are actually called precipitate. So when a precipitate is formed, we can say a chemical reaction or a chemical change has occurred. And that ends the lesson for today. I hope you guys learned something new, and thank you guys for tuning in. See you guys again next time. Don't forget to hit that like and subscribe button for more videos.